Welcome to the lecture on steel frame connection. In this lecture, I am going to explain what is connection, why connection is essential for steel frames and its behavior. So in steel frame, we'll discuss by seeing what is connection. Connection means is a medium through which the forces are transferred from one element to another element. For example, this is a sample figure to show the importance of connection. So in this case, here this is a beam is connected to a column. Whatever the load coming on the beam to be transferred to the column through the connection. So therefore connection becomes essential for transferring force from one element to another element. Then why we need connection in steel frame construction? We are not very much particular about connection in concrete. In steel frame connection, steel sections are manufactured to some standard length. This standard length based upon the type of rolling process, transportation and handling of sections at the site, for which the lengths are limited to some standard length. Hence, we need to connect those length to a required building element length. For example, if I need a beam length of 20 meter, the 20-meter length is not available in the market. I may get it from at a length of 10 meter. Then I do a connection between 10 plus 10 to get a 20-meter length beam. So this necessitates connection. Then we'll see how the connection behaves. So see here, I'll explain the behavior of connection through this beam column connection. This is a column and this is a beam connected by some connecting element. So here under the load, here what is expected is whatever the load coming from the beam to be transferred to the column. So during this process, because of it is not connected directly like your concrete, here an element is introduced for this transfer. Since this medium is again a ductile material, therefore they will undergo a small ductile behavior. So because of that, the beam relatively move with respect to the column. That means the beam rotate at an angle of theta r, but the column will be in the straight condition. So therefore the behavior of the connection has to be represented by its fluxure behavior, by representing the moment transferred to the connection to the rotation happen at the connection. So that rotation is said to be relative rotation. That is a relative rotation of beam with respect to column. Initially the beam and column will be at this particular plane. After the load is applied, because of the ductility present in the connection, because these connections are again made up of steel elements, it is in the form of angles or balls or plates, etc. Therefore that undergo a small ductile deformation which cause the beam to rotate an additional amount. But at the time at that case, the column is in a straight condition. Therefore this rotation is said to be relative rotation. So when we plot this relative rotation along the x-axis and moment along the y-axis, we'll get the behavior of connection. So mainly the connections are represented with respect to moment applied to the connection and how it is deforming under the moment, that is said to be relative rotation. So this is some of the common type of connection which is used in steel construction industry. We'll see from the simple connection, say single web angle connection. That means here again it is a beam to column connection where an element is introduced to connect this beam to column, that is a cleat, an angle of a particular length. So here the angle has two legs. This view is a side view, this is a end view, right? So in this case, one angle is connected, one leg of the angle is connected to the web of the beam and another angle is connected to the flange of the column. So such connections are said to be single web angle connection. When you go for the second connection, double web angle connection, it is nothing but the same behavior. Instead of single angle, two angles are provided on either side of the beam web. So, but the same behavior. One leg is connected to the web and another leg is connected to the column. Flange. The next connection is header plate connection, where a plate is welded to the beam web and brought to the flange and it is connected to the bolt. Such connections are said to be header plate connection. The next connection is top and seat angle connection. In this top and seat angle connection, the beams are connected to the column through the cleat. By here, the flange of the beam is connected to the flange of the column. In the previous case, the beam web is connected to the flange of the column. Here again, here beam web is connected to the flange of the column. But in top and seat angle connection, beam flanges are connected to the flange of the column. Here, there are two angles or cleats are provided at the top as well as seat. Since it is placed at the top of the beam, it is said to be top angle, and this is said to be because this angle is used to seat the beam on its position. Therefore, this angle is said to be seat angle. Therefore, this connection is said to be top and seat angle. This top angle may also called as a clip angle. So this is the end view of the top and seat angle connection. So see here what happened is, this is the length of the angle. You can limit your length up to the flange length or to the flange length of your, say here, flange length of your beam to the flange length of your column. This is the limitations we can have it in the top and seat angle connection. The other type of connection is top and seat angle with double web angle connection, where it is a combination of this web angle and the top angle and seat angle. So here, in addition to top and seat angle, the double web angle is also introduced here. So the reason behind the types of angle connections are nothing but we are gradually increasing the stiffness of the connection between the beam to the column. So see here, this is very light and slowly we are improving the connection stiffness. Then say this is said to be extended end plate connection. That means a plate is welded to the beam and it is brought to the flange and it is connected to the flange of the column. This is said to be extended end plate connection since the plates are extended beyond the height of the beam. Therefore, this is said to be extended end plate connection. Another one is flush end plate connection. That means here it is similar to extended end plate connection, but the plates are not extended beyond the height of the beam. Therefore, this is said to be flush end plate connection. Then the next will be T-step connection. That means here the beam and column is connected by a T angle rolled T section. The rolled flange of the T section is connected to the flange of the column and the web of the T section is connected to the flange of the beam. So this type of connection is said to be T-step connection. So here these types are mainly due to increase the stiffness of the connection between the two elements. So depends upon the stiffness, it should be compared by this moment rotation behavior. As I told that single web connections are very light connection. Therefore, what I explained by this graph is, so if any connection goes closer to this case, that means the moment here it is an XY plane. When I am taking anything which in this line, that means the value of the y axis on this x will be equal to 0. That means here moment will be equal to 0. That means here the connection which is showing a performance or a behavior closer to x direction, that means the moment carrying capacity of that connections are very, very small, but they can take the reaction coming from the beam. That means whatever the reaction coming from it will transfer, but the moment is the moment on the connection are not addressed properly or are not able to transfer properly by these connections. Therefore, these connections are said to be shear connection because these connections predominantly transfer the shear at the support but not the moment. But when you go to top and flush angle connection, where this connection shows a transfer of complete shear and also some moment from the beam. But here the extended end plate connection are said to be a connection where it is able to transfer larger moment as well as a reaction. So depends upon the stiffness, the moment rotation behaviors are changing. When any connection shows along this line, that is, it is said to be perfectly rigid joint. That means 100% of the beam moment to be transferred to the column. But in steel frame connection, that extreme, that is fully rigid and fully pinned cases are not possible, since the connections are made up of a ductile material using cleat angles, flats and bolts and welds. Therefore, here in steel frame connection, no connections are completely rigid connection, no or otherwise a ideally pinned connection. It is otherwise said to be steel frame connections are neither rigid connection nor pin connection. It behaves in between. Therefore, IS 800 2007 in its Annex F, it classifies the connection into three categories: flexible connection, semi-rigid connection and rigid connection. So the flexible connections are the connection shows very small transfer of moment from the beam to the column. Therefore, such connections are said to be flexible connection. There are certain connections which will transfer moment as well as shear. Therefore, that will be under semi-rigid connection. A certain type of connections which are transferring larger moment, relatively larger moment than the other two connections. Therefore, that connections are said to be rigid connection. Therefore, connections are said to be shear connection, small moment resting connection, and large moment construction, large moment resting connection. So I'll show a small video clip on beam to column connection, especially it is a shear connection, that single web angle connection. So I'm playing the video. This is a beam and this is a column. It is connected by a single web angle. Here one leg of the angle or cleat is to be connected to the web of the beam, and another leg of the cleat is connected to the flange of the beam through some group of bolts. So this is said to be single web angle connection. Next I will show another video where I will show a welded double web angle connection. See here, already the two cleats are welded to the beam and it is brought to the web of the column. Here, please see here, in the earlier case, the beam is connected to the flange of the column. Here, the beam is connected to the web of the column through two cleat angles. So, where the connection may be with the welded connection. This is again a beam to beam connection, where here this is a one beam, this is a secondary. Sometimes this is said to be main beam and secondary beam, but here there are two beams to be connected, both are equal in height. So we'll see how the connection is made. Again, a double web angle connection, this one cleat angle, another cleat angle on the other side. So where the web of the beam is connected to the web of the another beam. So this is again a beam, this is again a beam through a double web angle connection. So I'll another video clip on the same beam to column, beam to beam connection. See here, this is a beam and connected to a, this is said to be a main beam, a secondary beam. So this is connected to the main beam here. But both the case, please see here, the top of the connecting beam and this beam to be kept at the same level. To have that case, I'll replay it. A coping is made on the secondary beam. A coping, a cut is made on the secondary beam to have a level surface at the top. So this is about beam to beam connection when both the beams are having difference in the height. I will show the coping still in a better way in this view. See here, since the top flange of the secondary beam as well as the primary beam to be placed at the same level, the flange of the top flange of the secondary beam to be cut in a proper length, and this web has to be brought to the line of the web of the main beam. So if the secondary beam's height is equal to the main beam, then coping has to be done both in the bottom flange also. So this is the way the connection become done. So regarding the connection design, in our module we have two type of connection to be designed. One is double web angle connection, which is under the category of shear connection. The next one is top and seat angle connection. This is under the small moment resting connection. So in the next lecture I'll explain the design principle through a numerical problem. Thank you.